Let's explore solutions to systems of equations, and I'm going to make some connections between the equation and the graph because I can predict what's going to happen on that graph before I even graph it. So taking a look here, I have my red and green equation. The first thing you probably notice is they intersect. First thing I notice is these two lines have different slopes, and that is why they intersect, because they are rising or running at a very different rate. So somewhere on this grid, they will intersect. I could also see that in the equation. I don't have to graph it to recognize that the slopes are different. I can find it in the equation if they are written in slope-intercept form. So we know they both intersect, so what does that mean? It means that at that point, it is a solution to both equations. That point represents something that is true for the blue and the red equation. So we're going to talk about that more when we get to word problems. It will be the point where the variables are exactly the same for both situations. It also means that algebraically, if you were to substitute that coordinate pair, you would get a true equation for both. And you're going to do that quite a few times during this unit as well. So let's get into some hotspots. First thing I want to address, yes, the slopes can be different. It does not mean that one has to be positive, one has to be negative. I can have two lines with a positive slope and they will intersect. As long as the slopes are different, somewhere eventually they will intersect. And the other hotspot, sometimes kids will look at an equation and because one is in standard and one is in slope-intercept form, they won't look at the slopes. But we know how to change a standard equation into a slope-intercept form. And that way you can look to see, do they have different slopes? If so, yes, you will have one solution. Let's look at when we have no solution. Here we go. We have a red and a green equation. So first thing, clearly you can see the two lines don't intersect. They are always the same distance apart, and that's because they are parallel. They are never going to get any closer, any further, so they will never intersect, which is why there will be no solution. These two lines have the same slope. You can see it in the equation, 3x, 3x. But they have different y-intercepts. One has an intercept of 0. The other one has an intercept of -2, 0, -2, and 0, 0. So when you write an equation in y-intercept form, you can look at, yes, the slope. And if the slopes are different, we know there's one solution. If the slopes are the same, look at their intercepts. If they have different y-intercepts, then these two lines are never going to meet before you even graph it. So here are some hotspots. First one, you might, again, have an equation that's not in y-intercept form. We know how to deal with that. You may not have a b in the equation. Like, look, we have y equals 3x. So sometimes you may miss comparing the intercepts. So don't forget, you can just add a +0 and now you can compare the intercepts after the slope. And the other thing that happens a lot, sometimes it'll be represented like in a fraction and a decimal. And because they look in different forms, kids won't recognize that the slopes are the same. So that is just another hotspot to just be on the lookout for. It is easy to make an apples to apples comparison when you make everything the same in form. So let's look at our next one, which is when we have infinite solutions. And here you're probably saying, I only see one line. Yeah, because both lines are overlapping. My red line and my blue line are in the exact same places and they made a purple line. Both equations have the same coordinate pairs. They have all the same points because they represent the same points on the grid. They are the same lines. You'll also recognize they have the same slope and they have the same intercept. You can see it more so on the graph. These equations are not written in y-intercept form, but if I change them, you would see they are the exact same equation. So here's your look for. Look at the equation. Just look at it, and if you notice that m and b are the same and in the same form, then you have the same line. That means all the points will be the same. Every single point is a solution, which is why we say infinite solutions. So here's our hotspot. We know what to do about this. We know that the easiest way to compare the equations is just put them in the same form, y-intercept form, and compare your m and b. And here's something tricky. The equations may not be in simplest form. Like, look at the blue one here. I have to distribute. Once I distribute that 2, I can now put it into a y-intercept form. So just be on the lookout for those things. But now you have an idea of what it means, what it looks like graphically to be one solution, to have no solutions, or to have infinite solutions.